from this point draw vertical line, and from this point draw horizontal line. So this shows the axis of this solid. So join that axis. This upper face which is visible, lower face which is not visible. So this face is visible, this face is visible, and this face is visible. So if you look from the top, this pentagonal face would be visible. So join all these points A, B, C, D, E with the full line, rest all with the dotted line. But here outside lines should be joined with the full line, and 4 and D, 3 and C would be visible. So join them with the straight lines. This is the axis of this solid, and this dotted line represents this hidden portion. Say 5, 1 and 1, 2 would be invisible. So join 1 with 5 with the dotted line, 1 with 2 with the dotted line, and edge 1A to be represented with the dotted line as it is towards the behind side, so it will not be visible. Name the views. This is front view and this is top view. So I hope the solution of this problem is clear to you. First we have drawn top view, then front view, then tilt this front view at an angle of 60 degree, take projection, and this is the top view of given problem. So till now we have covered this prism. Now second type of solid, that is solids of revolution or type 2 solid. Now what do you mean by solids of revolution? The solids of revolution, when some of the plane figures are revolved about one of their sides, solids of revolution is generated. For example, cylinder and cone. These are the solids which are generated by the revolution. If we revolute the triangle, the cone would be generated. These are the solids of revolution, cylinder and cone. You can see here. Here cylinder and cone both are curvature by nature, and cylinder is formed by rotating a rectangle about one of its side, and the triangle, this cone can be generated by rotating a right angle triangle about its one side other than its diagonal any sides. We can form the cone. Now solids of revolution may be of following types. The first is cylinder and the second is cone, sphere, ellipsoid, paraboloid and hyperboloid. These are the solids of revolution formed by this. The cylinder is formed by rotating the rectangle, cone is formed by rotating triangle, sphere is formed by the rotating either semicircle or full circle, or semicircle is rotated about its diagonal, then we can generate sphere. Ellipsoid can be formed by semi-ellipse, paraboloid can be formed by rotating the parabola, and hyperboloid can be formed by rotating hyperbola about its base. Now cylinder. What's a cylinder? It's a right regular cylinder is a solid generated by the revolution of a rectangle about its vertical side, which remains fixed. One side remains fixed like this. This is axis rectangle. If we rotate the rectangle like this, it will form a cylinder as shown over here, and this is called as the base of the cylinder. So cylinder is having two circular base, upper base and lower base, and center of both these upper and lower circle are joined with the axis, so it is called as axis, which is the fixed line of this rectangle about which the rectangle is rotated. Now second, that is cone. A right circular cone is a solid generated by revolution of a right angle triangle about its vertical side, which remains fixed, and this vertical side is called as the axis of this cone. So this is the axis of cone, and about this axis of cone, this is the right angle triangle which is rotated about this axis, this vertical side, so it forms a cone, and this circular base is called as the base. This slant edge is called generators, and this is the axis of this cone. Now important terms related with the solids. First is edge or generator. What do you mean by edge or generator? For pyramids and prisms, edges are the lines separating the triangular faces or rectangular faces from each other. That is called as the edges. For cylinder and cones, generators are the straight lines joining different points on the circumference of the bases with each other. And for cone, the points on the circumference are joined to the apex point, and we can form the generators. Apex of solid. The definition of apex of solid: for cone and pyramids, the apex is a point where all the generators are or the edges meet. That is called as apex point, or this is apex point. So we can join the edges to one point, and it makes the apex point as shown over here. For cone, this is apex point. For pyramid, this is apex point. For this prism, these are the terms which are useful. This is called edge. This is axis, upper face, lower face. For cylinder, base, rectangle, axis, and generators. Axis of solids. What do you mean by axis of solid? So for cone and pyramids, axis is an imaginary line joining center of the base to the apex. The center of base is joined to the apex. It is called as the axis of solid. So for pyramid, this is axis. For cone, this is the axis. Axis of solids. For cylinder, this is axis. For prism, this is axis. And for cylinder and prism, the axis is an imaginary line joining centers of ends or bases. Here the center of circles are joined, and we can draw the axis of the cylinder, and center of this hexagon, upper hexagon and lower hexagon, it forms the axis of this hexagonal solid. Right solid. What do you mean by right solid? A solid is said to be a right solid if its axis is perpendicular to its base, as shown over here. If this axis makes an angle of 90 degree with this base, it is called as the right solid. And fourth one is oblique solid. What do you mean by oblique solid? A solid is said to be an oblique solid or an oblique solid if its axis is inclined at an angle other than 90 degree to its base, as shown over here. So in this solid, this axis does not making an angle of 90 degree with the base, it is at certain other angles, so it is called as the oblique solid, or this is an oblique hexagonal pyramid. Now second example, the data is given like this. A cylinder, diameter of the base 100 mm and height 140 mm is resting on HP on a point of its periphery of the base. The axis of cylinder is inclined to HP by 30 degree, and the axis is inclined at 45 degree to vertical plane. Draw the projections. Keep top end of the cylinder nearer to observer. This condition is given to us, and here the cylinder is given, diameter and heights are given to us, and we have to, this is the cylinder and this is the data given to us. A cylinder 100 mm diameter, 140 mm height, resting on HP, and axis 30 degree to HP, 45 degree to VP. Whenever you solve such kind of problem, you should write the given data in short form like this. Now draw XY line which represents intersection of both the planes HP and VP. Draw axis of this cylinder. Draw a circle below XY line of diameter 100 mm or 50 mm as a radius, and its front view having height is equal to 140 mm by taking projection from the top view and draw this front view. And here it is given that the axis is inclined at 30 degree to HP. So rotate or tilt this front view at an angle of 45 degree with 30 degree with XY line. So redraw this rectangle, the same rectangle at an angle of 30 degree with XY line, and draw its top view. Now how to draw this top view? Let me do this exercise over here. How to find out the top view? Till now we have drawn. Now name the endpoints. So first we will divide this circle into 8 equal parts. After that, dividing the circle into 8 equal parts, let me take projections from here. Say 1, 2, 3, 4, 5, 6, 7 and 8 are the name of views in the top view, and 1 dash, 2 dash are the points on the front view. Now we draw from 1 dash. 1 dash is here. So this is point 1 dash. From this point 1 dash, this is point 1 dash. From this point draw straight vertical line like this, and from this 1, here is point number 1. We can see this is point number 1, here is point number 1 dash. So from this point draw straight horizontal line like this, and both this will meet at this point. This is point number 1. Similarly, point number 2 dash is here. So from 2 dash draw straight vertical line. From 2 point is here. Here is point number 2. 2, 3, 4 are the points. 5, 6, 7 and 8. 8 points are there. Similarly, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash. Transfer these points 2, 3, 4, 5 or 5 dash, 6 dash, 7 dash, 8 dash and 1 dash. So point number 2 would be, if we draw horizontal line from point 2 dash, point number 2 would be somewhere here. Here is point number 2. Similarly, point number 3, vertical line from point 3, horizontal line from point 3, 3 and 3 dash. Here is point number 3. Point number 4, similarly by transferring the points, point number 4 would be here, point number 5 would be here, point number 6, horizontal line from point 6 and 8, vertical line from point 6 and 4, that would be somewhere here. Point number 5, vertical line from point number 5 would be here. So here is point number 6, here is point number 7, point number 8. So horizontal line from point 7 will come over here. So these are the projections taken from this top view and vertical lines from this front view. So join all these points 1, 2, 3, 4, 5, and if you look from here, if you are looking from here, then this upper face 1, 2, 3, 4, 5, 6, 7, 8 would be visible to us, and hence join all these 1, 2, 3 point with the full line, and curvature shape would be there. So this is the elliptical shape joined with the full line which is visible to us. Now what's about this bottom face? So here is the point 1, 2, 3, 4 and 5, and 1, 2, 3, 4, 5, 6, 7, 8 points are there. So by taking projections from this corner, from this point, we can take projections like this, and we can find out the points positions 1, 2, 3, 4, 5, 6, 7, 8 and back to 1. Join all these points with the smooth curve. But what's about this bottom face? It's not visible, hence these outside points should be joined with the full line as joined over here, and these internal points should be joined with the smooth curve with the dotted line like this, and join the edges. So this represents the top view and this is the second stage. Now in the third stage it is given that this axis, now here in this case this axis makes an angle of 30 degree with HP. So insert this dimension 30 degree with XY line. So this axis makes an angle of 30 degree with HP. Now second step it is given that this axis makes an angle of 45 degree with VP. So here we can say this is the axis of this solid as represented by this red colored line. This is the axis of this solid, and the angle between the axis of this solid and XY line is parallel to each other. So angle is 0, but in given data this axis makes an angle of 45 degree with XP with XY line. So we have to draw this axis such that it makes an angle of 45 degree with XY line. This angle is 45 degree. So draw a line at an angle of 45 degree with XY line and transfer all these points over here such that that angle is 45 degree. So we can transfer the points and we can redraw this figure, and that would appear like this. This is the visible and this is invisible portion, and this is the outside line of this cylinder. So it is just redrawing of this view. Now by taking projections we can find out the position of this solid in front view. So 1, 2, 3, 4, 5, 6, 7 and 8. That would be somewhere here. So from all these points draw the lines, vertical lines, and from all these points draw horizontal lines, and we can find out the position of various points. 1, 2, 3, 4, 5, 6, 7 and 8, and the points of intersection would be somewhere here, and join all these points with the smooth curve, and all these points would be visible to us, because if you look from here this base is towards us, so this all the points would be visible to us. So join them with the full line, full curve. Similarly in the bottom side here also, by taking